All right, people, we are in a new section, new unit as well. We are in unit 2, and we're talking about linear equations, linear relationships, all that good stuff. Linear functions, yeah, that good stuff. So let's get started. So last year, you all learned about the constant of proportionality. That sounded crazy when I said that. Constant of proportionality. So this is what we learned last year. Constant of proportionality. We learned about COP, whether your teacher called it COP or not. We learned about this last year. So the constant of proportionality is K, a constant, such that you get Y over X. So what we did last year is that we said, hey, it has to start, must start at the origin. All right, let me get this handwriting together because this looks bad. All right, so this is our origin right here. And so we said that in order to find the constant of proportionality, we take the Y over the X. So the Y goes up. All right, y'all, let me get my life together because this looks a mess. All right, so the Y goes up 2, so that's 2. And then the X goes over 1. This is what we did last year, right? And so we make these triangles. These triangles are important. And you go up 2 over 1 every time. And we say we can find the COP by just taking your Y value and dividing it by your X. So we don't do 0, 0. Again, we don't take the 0, 0. But if we take the 2, make sure y'all can see the pen tool. If we take the 2 and divide it by the 1, so if we come over here and say, hey, 2 over 1, that gives me my COP. And then that gives me 2. And then we say 4 over 2, that gives me 2 as well. I'm going to go real slow for some of you all because, not some of you all, I really need to take this slow because I'm building a foundation and I'm not here to build it with you. Oh, so sad. All right. So we say we can take Y over X and that gives us the constant of proportionality. Remember doing this last year? Basically, you're saying, hey, how do I go from 1 to 2? How do I go from 2 to 4? Because if it's proportional, it should be the same thing every time. So we say 1 becomes 2 by multiplying by 2. I should put a dot there, not an X. Come on, Mr. O'Neill. Up your game. Multiplying both by 2. So that's what we did last year. Y'all did this over and over and over and over again last year. So we're not going to do the constant of proportionality. Instead of COP, we have ROC. Look at there, COP, ROC. We have ROC, which is rate of change, all right? So the rate of change is the rate at which one quantity, Y, changes in relation to another quantity, X. So rate of change doesn't necessarily have to be X and Y, but we're going to deal with X and Y because we're dealing with lines. So the rate in which one quantity, Y, changes in relation to another quantity, X. So look, they're very similar. COP is Y over X, so we just take the Y and divide it by X. Don't write this down. I want you to see this. Can we find, well, write this down. Sorry, I'm going to do this first. So if I do this with the graph, if I come up here like that, and then I go over like that, I still get 2 over 1. I go up like that, go over like that. I still get 2 over 1, but for a rate of change, it does not have to start at the origin. Okay, so this is what I don't want you to write down. So if I do this, let's go to the galaxy. We're going to leave lava and go to the galaxy. All right, so if I say, let's use the same method. If I put 4 over 1, gives me 4. If I do Y over X, like I did over here, don't write this down. Don't write this down. And then I do 6 over 2, that gives me 3. Well, that's not what we get when we do this line. It's 2 over 1. That's 2 over 1. That's 2 over 1. So we cannot take COP and apply it to ROC. Hey, COP can't apply it to ROC. Hey, so don't do that. You cannot apply COP to ROC. ROC is rate of change. And now I can tell you what this triangle means. This triangle means the change. Triangle means change. So we read this as the change, write that down, in y over the change in x. That's how we write this down. So roc is very similar to cop, but rate of change, roc, rate of change, it is the change in y over the change in x. That triangle means change. It's the symbol for change. All right. So if that's the case, the y's, I'm going back up to my graph right here. My y's are changing by 2, and my x's are changing by 1 each time. Remember, it's the rate at which one quantity y changes in relation to another quantity x. So it's going up 2 over 1, up 2 over 1. So that's the change. That is the change. And so in my table, unlike over here when we could say y divided by x, y divided by x, I cannot do this. Don't write this down. I can't do this. 0 to 2, 1 to 4, 2 to 6, because that number is different. 1 times 4 gives me 4, and 2 times 3 gives me 6. So I can't apply that. What I must do, you will be writing this down. What I must do is find out how are the y's changing. So how does 2 become 4? What am I doing mathematically? I am adding 2. I have a feeling somebody's not, like, you're just writing stuff down. You're not listening to me. Listen to me, y'all. Listen to me. How does 2 become 4? You add 2. Well, how does 4 become 6? You add 2. Now, I know these don't look like the triangles that we had up here, but technically, you know, if I really get technical on you, if I say, like, if I do something like that, I could make a triangle like that. So you can remember that with roc, you have to make the little triangles on the side as well. Or some people call them the mountain peaks or whatever like that. But the y's are changing by doing what? Adding 2 each time. How are the x's are changing? Well, 0 becomes 1 by adding 1. 1 becomes 2 by adding 1. So what's the change in y? The change in y is a positive 2 over the change in x, which is a positive 1. Y'all, when I tell you that this lesson, that is like 95% of the lesson, y'all, when I tell you that's 95% of the lesson, I'm telling you the truth. I'm not lying to you. So the change in y is 2. The change in x is 1, and rate of change, or slope, I haven't said that word yet, slope, used by the variable of m. Miss Gorman told me that m stands for the modulus of the slope. I never knew that. I was like, where did they get the m from? She told me that. That might be an extra credit question. What does the m stand for? The modulus of the slope. All right, so how is the slope modulating? So that's what the m stands for. It's going up 2 over 1. The change in y over the change in x. And we see that in the graph as well. Y'all see that? 2 over 1, 2 over 1. And that's the meat of the lesson, y'all. And I'm going to say the same thing over and over again, and y'all become experts at it, and we're going to just kill this next test, and we get more mathletes. All right, so it says find the rate of change for each ray, then find it in the table, and then use the rate of change to find the missing values. All right, so the rate of change is the change. What I write, you write. Change, that's supposed to be a triangle. Come on, Mr. O'Neill. Change in y over the change in x. And we know rate of change is the same thing as slope. Those words are used interchangeably. You see what I did there? You see what I did there? I'm glad you did. All right, so how do I find it? Well, we draw a triangle. So I go from this dot. Trying to go, come on, cursor. I'm trying to go from this dot right here to this dot right there. So how do I do that? So I'm going up 1 over 1. So that's 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. So what is the roc? The roc, or the rate of change, is equal to, and we're going to always write these as fractions. You'll see it simplified in the future, but we just need to remember it's going to be as a fraction. Change in y over change in x. The y's are changing by a positive 1. The x's are changing by a positive 1. So roc is equal to 1 over 1. Or we can say that m, which is the variable for slope, is equal to 1 over 1. They're both the same thing. I have to find a way that I'm going to differentiate between the two when I say, hey, I guess, well, I don't know. I figured it out. So let's look at the table here, everybody. So let's come out here in the table and see the same thing. How does 0 become 1? Our mountains that we can make, triangles if we want to. 0 becomes 1 by adding 1. 1 becomes 1 by adding 1. Sorry, 1 becomes 1. 1 becomes 2. 2 becomes 3 by adding 1. 3 becomes 4 by adding 1. Well, how are the y's changing? That's the y's. The x's. Notice I don't start with the x's. You know why I don't start with the x's? Because rock and slope, or M for slope, is y, changing y over the change in x. I do not start with the x's. I start with the y's, so I don't get confused. So that is going to be 1 over, how does 0 become 1? Add 1. Add 1. Add 1. Okay, 1. Please note that 0, 0, the order pair 0, 0 is found at this dot right here. All right, the order pair 1, 1 is found at this dot. The order, I'm going to change these to a different color. Let's make them, what color y'all want? Come on, drop down color. Let's take them to green. There we go. So the order pair of 1, 1 is found here. 0, 0 is found there. 1, 1 is there. 2, 2 is here. 3, 3, 4, 4, 5, 5. All right. But 5, 5 is not in the table. Well, we get the point. Okay, back to the galaxy. All right. So let's come over here and find the rate of change, or the slope. The rock is going to go, how do I get from, we're going from, don't forget y'all, we're going from dot to dot. We're going from this dot to this dot. How do I do that? I go up 1, then go over 2. Up 1, 1 over 2. Over 2. Up 1, over 2. And so my rock is going to be change in y over the change in x. And my slope, which is M, is going to be change in y over the change in x. Okay? So that's that. So let's reproduce that in the table, because our order pairs should be the same thing. So when I come over here in the table, let's go back to this green again. So 0, 3 is right here, right there. That's 0, 3. All right, 2, 4. So how does 3 become 4? Adding 1. How does 4 become 5? Adding 1. How does 5 become 6? Adding 1. So what is this missing value? What is the pattern? I'm adding 1. So my next order pair would be 7. My y would be 7. How does 0 become 2? Adding 2. How does 2 become 4? Adding 2. How does 4 become 6? Adding 2. So 6 becomes 8. So we should have 8, 7 as the next order pair. So what's my slope, or my rate of change? It should be the change in y over the change in x, and that is going to give me 1 over 2. All right, so I'm going to save the next one for you to do on your own, because that's going to be, I'm making up the homework. I wasn't going to do that, but I'm going to make that to be the homework. So what I don't do in the notes becomes the homework. All right. So this one says find the rate of change of each ray, then find it in the table, and then use the rock to find the missing values. All right, so the rate of change, or the slope, same thing, is the change. Oops, you gotta do that. Come on, man, don't start acting weird. It's going to be the change. Stop it. Change in y. If I write it, you write it over the change in x. If somebody knows where Chris Enos is at, just tap him and make sure he's doing his work. I just got a feeling. If you know Asa, tap him, make sure you're doing his work. If you know Malia Curry, tap her, make sure she's doing her work. Latasha, hopefully I didn't put them together. Tap them, make sure they're doing their work. All right, so we do the same triangles. I'm going from this dot right here to this dot right here. How do I do that? I go down 2 to the right 1. So that's going to go down. I probably need to move this a little bit. Sorry, buddy, I gotta delete you. Move you up here or something. Changing y over changing x. All right, so I went down 2, that's -2. And then I went to the right 1. So I went right 1, that's negative 2. We should know that from translations, y'all. We went down to the right 1. All right, Miss O'Neill, get these triangles together. So my rock, I didn't leave a lot of room here. My rock is going to be negative 2 over 1. Or my slope is going to be negative 2 over 1, rate of change. So let's look at this. Let's see if we can make sure we can find this in the table. So we went down. How does 2 become 4? How does 4 become 2? Subtract 2. How does 2 become 0? Subtract 2. So if I subtract 2 here, 0 minus 2 is a negative 2. And if I subtract 2 here, negative 2 minus 2 is a negative 4. All right. How does 0 become 1? Add 1. How does 1 become 2? Add 1. How does 2 become what? 3. Add 1. How does 3 become what? 4. Add 1. So my slope, I'm going to put rock at the top and slope at the bottom, is going to be negative 2 over 1. All right. Let me slide this down a little bit. Okay. So let's do this one. So I'm going from this dot right here to this dot right here. Maybe I should do that when I'm trying to emphasize stuff instead of the little cursor so y'all can see that. All right. So I need to go, remember we go Y first. We do not, notice I have never done this. Notice I've never done this. I've never gone over first. You know why I don't go over first? Why? Because it's Y over X. It's changing Y over changing X. So you've noticed, you've never seen me do that. And I will never do that. Okay, some of them like, it's the same triangle. It's the movement. Down 1. So if I go down, that's negative 1. To the right, 2. All right, so that's positive 2. So my rock is going to be down 1 to the right 2. Down 1 to the right 2. So that's going to be negative 1 over 2. Let's see this in the table. How does 3 become 2? Subtract 1. How does 2 become 1? Subtract 1. How does 1 become 0? Subtract 1. How does 0 become what? Negative 1. They don't look like a negative 1. All right, negative 1. How does 0 become 2? Add 2. 2 become 4. Add 2. 4 becomes 6. Add 2. 6 become 8 by adding 2. So my slope is going to be y, negative 1, changing y, over 2, negative 1/2. This one is homework. Hold it down. All right. Use your triangles to find as many dots on your line. Then use the dots to extend the table for your ordered pairs to confirm the rock or slope from the graph. All right, so this is where I need to go to the select tool so y'all can see this. All right, so when I look here and I look here, if I go from this dot to this dot, then my rock is going to be up 2 over 1, right? So we notice that the rock has been constant. That's why the line is straight, because the rock has been constant. So if I choose to use that, then if I keep that same pattern, I know that I will go backwards. If I go backwards, let me go to the tool so you can see. If I go backwards, I go up over here, then I want to go the other way. And I don't want to go left and then go down. It'll make sense to do that, but I'm not going to do that because I just said in the video, I'm not going to go left and right first. But it wouldn't make sense, but I just don't want y'all to start doing it. So I need to go, the next dot would be here. I want y'all to see it first. Come on. Come on. Where you at? I might have to find my mouse. All right. So right. All right, I'm back. So this is the dot right here. And so I'm looking where this crosses the next line or goes through the next corner. It's right there. So I'm going to put a dot. Let's make the dot black this time. Put a dot right Whoa, I'm really off. Okay. Right there. That's what I'm trying to do, y'all. All right, and the next place, if I that looks a mess. If I follow, let's just do this, Mr. Odell. We're gonna. I was about to say cheat, but it's kinda because I'm using my technology. All right, so if I just do that, then I can make the dot. Ooh, kill him, Mr. O'Neill. And then the next dot would be right there. The next dot would be right there, and the next dot would be right there. All right. If I come up here, the next dot would be right there. Okay, so if I use these dots, and I'm going to say put no more than 5, and start from the least to the greatest, okay? The least x to the greatest x, and no more than 5, because I'm not going to have y'all doing this forever. This video is going to get extremely long. I'm going to try to have it no more than 35 minutes. Somebody's like, 35 minutes? 15 more minutes? Yeah, because y'all need to learn this lesson. It's like me teaching in class, so shut up. All right, yeah, I said shut up. Shut it up. All right, so let's look. So where am I going? I done lost my train of thought talking to y'all, but not really talking to y'all. Okay, so yeah, the original slope or rate of change, change in y over the change in x, the original rock that we found was what? 2/1, right? Okay, because we went up 2 to the right 1. So each point should be up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. So it says use your triangles. We just did that. We just used our triangles to find as many dots as on the line. We just found all the dots on the line. Then use the dots to extend the table. That's what we haven't done. So we know how to find order pairs now because we did that all in the translation unit. So there's no need to acting like we don't know how to do that. So what is this order pair down here? Well, if I start at the origin, that is 1, 2, 3, 4. So that's -4, -4. Whoa. I hate when it does this. You say redo, and it's like, oh, I'm going to go back and do something else. I said redo. So -4. And then that is 1, 2, 3, 1, 2, 3, 4, 5, 6. Boy, I can't count. 1, 2, 3, 4, 5, 6. So that's -4, -6. And then the next dot would be over 1, 2, 3. So that's -3. And then that's down 1, 2, 3, 4. So that's -4. And then I'm going to do one more and let y'all figure out the rest. So this is -2. And then this is down 2. So you're going to find the last two. I want 5 points. All right, people. You're going to find the next two. But I'm going to do this before you find the next two. Let's let this thing lose some weight. There you go, buddy. All right. So what I should notice is that if my slope is 2/1, I should see that I'm adding 2 each time. And then I'm adding 1 over here. I'm adding 2 each time. And then I'm adding 1 over here. So you can use that pattern to find the last 2 order pair because I want 5. All right, so let's look at this one right here. All right, Mr. O'Neill, we got like 10 minutes left. You might have to tell these kids a little fib or something. All right, so if I look at this dot and I look at this dot, right? So let's find the actual rate of change from the, come on, man, from this problem. All right, so notice to get from this dot and this dot, I always go from left to right. Gosh, I forgot to tell y'all that. Shoot. But you'll hear it now. I always go from the left dot to the right dot. So, and the way that I do that is that I need to go from here to here, but I go Y first. So I go down, how many? That's 1, 2, 3. So that's -3. Come on, 3. And then I'm going over 2. So if I use that, I need to find the next pattern. So I go down 1, 2, 3 to the right 2. Notice it's this point Let me use my little cheating tool. Notice this is this point right here that's on the corner. Hopefully y'all see where it crosses corners. That's how you put your dots, where they cross the corner, where they cross the corner. I might have to do that in person with some of y'all. So that's down 3 to the right 2. So what's the first order pair to the left? Remember, we put the smallest number first. Somebody's calling me. Hold on, I'll be right. All right, I'm gonna call my dad back. All right, so the dot to the left of this is going to be -2, and that's 1, 2, 3, 4. So that's -2, 4. This dot right here is going to be 0, 1. 0, 1. This dot right here is going to be 1, 2, -1, 2. 2, -2. All right, so let's see if we can see our slope. You're going to find the last two. Remember, that's your homework. You're finding the last two. Okay, let me let my dot lose a little weight. You're finding the last two. That's your homework. All right, so if I do that, I'm saying that my rock, I didn't write down the rock for this one. So we're saying that the rock, the rate of change, is going to be what? Down 3 to the right 2. So I should see subtracting 3 over here and then adding 2 over here. Subtracting 3 over here, then adding 2 over here. And that's exactly what I see, because that's the rock or the slope. So M, you need to gain a little bit more weight, put a little bit more meat on your bones. So M over here, this first one was 2. This will be an equal sign. Is equal to 2 over 1. My rock is -3 over 2. So my slope is equal to -3 over 2. I'm running into space. Y'all don't put it right there because you're going to run into space. So I want you to do this one right here on your own. That becomes homework. And I think I can get one more section of this before this video ends. And y'all be mad at me for how long this video is. But y'all know y'all miss me. I miss you too. Oh, yes, I do. Okay. So let's review what we have seen. We have seen these type of lines. When will we notice that the line is increasing? The line is increasing when the slope is positive. So let's go back up here and look at this. When the slope of these lines were positive, we see that it's going where? What direction is it rising? Because that's what we are going to talk about slope as well. I haven't really stressed that yet, but we'll stress that in a little bit. So the slope is going to be equal to how the line is rising and what direction it is running. So when I say that, I'm going to highlight this line real quick. Highlight this line. So this line is rising up to the right. Right? You see that? You look from left to right, it's rising up to the right. So how do you describe a positive slope? Rises to the right. All right. So if I say we describe slopes by how the line is rising, what about a negative slope? A negative slope is doing what? It's rising to the left. So when we go back and look at our points back here, we will see that, hey, this line was rising to the right. No wonder we got a positive rock or a positive slope. This line is rising to the left. No wonder we got a negative rock or a negative slope. This line is rising where? No wonder when you do your homework, you got a what? All right. So those are what we've seen so far. When we came over here and went up here, these slopes were all rising to the right. We got all positive rocks. These slopes are necessarily rising to the left or going down. Down to the right. No, just leave it one term, Mr. O'Neill. If I extend this with an arrow, you'll see that it's rising to the left. Negative slopes. Rising to the left. Negative slopes. Rising to the left. Negative slopes. All right. So how would I describe a zero slope? A zero slope is a line that is horizontal. It's a horizontal line. How would you find a define an undefined slope? And we're going to get more into this tomorrow. I think I might have to end the video right here. I don't know. We'll see. Yeah, I think I am, because I want y'all to get started on the homework. Oh yeah. All right. So undefined slope is what type of line? It's a vertical line. I'm gonna give you acronyms for this come Monday, because I really want y'all to do this next part with me. I think Monday. So I don't know. I might make a small video tomorrow. Let me think to myself. Let me pause this. All right, I made up my mind. I am going to allow the problems that we did not do to be your homework tonight, and let that only be your homework tonight. So what am I saying? I'm talking about you do that problem right there. You do this problem right here to the right, and you do this problem right here for homework. And since this video is 30 some minutes long, you can actually finish it in the time that you are dispersed. All right, tomorrow will be another video on, I think I'm gonna make a front and a back worksheet for homework so that you understand what I'm expecting you to do. And that'll be the classwork tomorrow, and you won't have any homework unless you didn't finish the classwork. All right, so yeah, that's it. Like always, it's been great educating you today. Hopefully you learned something, because I did this good teaching, and I don't plan on doing this good. Oh, you need to gain some weight. Okay, you too skinty. We gotta gain you some weight. I don't plan on doing this good teaching without you learning. All right, that's what we're talking about. This has been another Beast Mode production. This is Mr. O'Neal. I'm out.